Hello everyone, welcome to the new video for physics past paper solution from Edexcel. This is January 2017 unit 1. Let's start. Question number 1. Which of the following expresses the joule in base unit? Okay, so joule is unit of work, and work, you know, that is force into distance or displacement. That means equivalent unit of joule is Newton meter. But we need to give answer in terms of base unit, and Newton is equal to kilogram meter second minus 2, and this is meter. So be careful. This is the Newton, this is base unit of the Newton, and this meter is there. So if you simplify this, you have a kilogram meter square and second minus 2. So your option is D. Question number 2. Select the graph that correctly shows the variation of an object's kinetic energy with velocity. Okay, so you need to see the graph between kinetic energy and velocity. Now let's look at the equation that relates these two, which is kinetic energy Ke, or you can say Ek as they are writing in the question. So Ek or Ke is half m v square. Since during the motion mass of object stays constant, that means kinetic energy Ek is you can say it is it is directly proportional to the v square. That means if you see the graph of kinetic energy and the velocity, and because of the square, you must have a parabola. So for your understanding, parabola. So for your understanding, if you recall graph of y is equal x square, this is a quadratic equation from your IGCSE mathematics. For graph of y is equal to x square is a parabola. Similarly, Ek and v square, or Ek and v square, it must be a parabola. So it cannot be your option. No, no, yes. So this is your answer. This is the half of the parabola. So your option is D. Question number 3. A block of mass m is placed on a bench and a horizontal force F is applied to the block. The block accelerates along the bench, travels a distance d in time t, and reaches the velocity v. The work done by a force F on the block. So they give you many quantity. So a particle, point A and point B, and a block of mass m is moving under the influence of F, and this block covers a distance of d in time t, and there's a change in velocity, and at the end it has a velocity v, and they are asking you to find the work done. If you see, the definition of work is W is equal to force into distance, F and D. So you don't need to involve V and time because F and distance are already given. F, so your option must be A. Question number 3, option is A. Question number 4. To travel from position A to position B, a car drives 20 km due east and then 20 km due south. Okay, from point A, from point A, 20 km due east and 20 km due south. Select the row from the table that correctly expresses the magnitude of the total distance. Okay. Travel and the total displacement. So it's okay. So remember, distance. Distance is a scalar quantity. So you just need to add the numbers that define distances. So 20 and 20. So your distance must be 40 kilometers. But displacement is a vector, is a vector quantity, is a vector quantity. And remember, when two vectors act perpendicularly, listen carefully, if any two vectors are acting perpendicularly like these, if I say this is a vector A and this is vector B, they are acting perpendicularly. So their resultant, which is in that direction, this is the resultant of A and B, and A and B are perpendicular, so resultant are always is found using Pythagoras theorem. So R square is equal to A square plus B square, or if you remove the square, so you must use the square root, so you can say R is equal to A square plus B square root. So this is how that you can find the resultant if two vectors are acting perpendicularly like these two. So this is the first displacement vector, this is second, both are acting perpendicularly, so resultant displacement would be Pythagoras theorem of 20 and 20. So this is the distance column, and we have defined that the 40, so it cannot be this, cannot be this, any two of C or D. And of course for C, the displacement column is, this is Pythagoras theorem, so your option is C. This is your option for this MCQs, C. Question number 5 and 6 refers to information below. Two groups of students were asked to perform an experiment to determine the acceleration of free fall. Each group repeated their experiment 3 times to check their results. In each experiment, a steel ball fell through a height of just under 1 meter, and time for the ball to fall was measured. Group 1 uses a stopwatch, okay, and measure the time. Group 2 use light gates and data logger to measure the time. Okay, so the student measure the height the ball fell using a meter rule. The height should be recorded as, it's all about uh, significant figures. Remember, significant figures. If you see the meter rule always measured any measurement till 3 significant figures. Okay, for example, any length of rod, this is a rod, and if you measured a length, and let's say the length that you measured is 10.4 centimeter, I'm talking about in centimeter. So how many significant figures are there? 3 SF. Even if you convert this into meter, so it will be 0.0104. Sorry about that. Of course, it's not. Yes. So divided by 100. So it will be 0.104. So you see it is 3 significant figures. That means it contains only 2. This is also 2. This is also 2 significant figures. This is 3 SF. 3 significant figures. So you must record the measurement as in C. So your option is C. Question number 6. Select the row from the table that correctly describe the reliability and validity of the result obtained for each group. Group 1, remember group 1 is using a stopwatch. That means reaction time is involved there. Reaction time. So due to reaction time, group 1 is not reliable. That means you cannot choose option B, no, and option D. You can choose only A and C because of reaction time, it is not results are not reliable. But if you see, the group 2 is using light gates and the data logger. So for A, yes, now of course it is reliable. For group 2, the method is reliable because there is no reaction time involved. Readings taken automatically. Everything is automatically, no human observation is involved. So meaning group 1 reliable, valid. Yes, so your option is C. Question number 7. An object of volume 2.4 times power minus 5 meter cube was suspended from a spring balance in air, and its weight in Newton was read from the scale. The object was then placed in a measuring cylinder containing water of density 1000. The reading on the spring balance is, of course, it's quite easy, because whenever you put some object in a fluid, so remember, when an object immersed in a fluid, its weight is decreased. Its weight is decreased. Okay, why it is decreased? Because of upthrust. And Archimedes principle says that upthrust is density into volume into acceleration due to gravity. So this is the upthrust that acts when an object is immersed in a fluid. So if the weight is W, and after putting in the fluid, upthrust start acting, so its weight should be decreased. And if you see, you cannot choose increase and increase, the weight must be decreased, so any of the A and B. And if you see, upthrust is rho Vg, density into volume into acceleration due to gravity. So there's no G involved, so you cannot have option A. So only option is, because if you see this is your rho, this is your volume, and this is your G. So your option must be B. Question number 8. A uniform rod is found to balance when a pivot is placed at a midpoint O as shown. Okay, this is the pivot. The rod is replaced with the one made from two different material. The right hand half of the new rod has double the density but half the diameter of the left hand half of the rod. This is the right hand side, the new rod. It has half the diameter but double the density. Okay, so let's just talk about what should be the weight of this new rod. Weight, and if you see, weight is equal to mass into acceleration due to gravity, mg. And in fact, mass depends on density and the volume. So you can write W is equal to rho v g. So g is not changing. So you can say uh, weight depends on density and the volume. So the new weight, let's say the new weight is called W dash, weight of the right hand rod. W dash, what is happening? Density is doubled, so 2 times, okay, and the volume is half. Volume is half. And if you see, this is all about a rod, and the rod volume is pi r square L because it is a cylindrical in shape. That means length of both rod is same, so volume depends on radius. Volume depends on radius. What are they doing? Diameter is half of this new rod, so radius is also half. So if radius is half but we have r square, that means half of a square. So density is double, volume depends on radius, and radius is being halved. So 1 upon 2 of a square. If you simplify this, so 2 times 1 upon 4. So 2 and 2 cancel. That means half. So weight of the new rod is half of the old one. That means left hand side is heavier. It is heavy than the right hand side. So that means the center of gravity, this O, should shift left of O somewhere here to balance the rod again. So O must shift left of O. Option is B. Question number 9. Concrete is used in both spans and a supporting column in a bridge. The spans need to be reinforced with a steel, but the supporting column do not. These are okay, supporting column. This is because concrete is okay, strong under both tension and compression, is strong under tension and weak under compression. Now of course, due to weak under compression, it is not possible, and it is not strong under tension. That's why A and B is immediately gone. Yes, weak under both. No, weak under both tension. No, it is strong under compression. So because of, so weak under tension and strong under compression. That's why you can make a column of concrete, so it can bear a compressive stress. So it is weak under tension and strong. So your option is D. So let's say question number 10. A 1.8 kilogram mass is suspended from the end of the spring of the original length, 0.04 meter. The spring extends and is now 3 times its original length. The work done on the spring is so let's say you have a spring. This is the spring. All right, let's say this is the spring. This is the original length of this spring till here. And what do? You support the one end of this spring, and then what are you doing? Due to some force, this spring is a stretch, and the new length of the spring, so the original length is L0 and the new length is L, and L after extension they are saying it is 3 times the original length, so L is equal to thrice of the L naught. So the work done on the spring, it's all about elastic potential energy, or the work done on a stretch spring. So if you see, the work done is half of Fx, and remember F is the weight and X is the extension, which is delta L. So you can rewrite that half mg into delta L, and delta L is L minus L naught, which is, of course, you can say 3L minus 3L naught minus L naught, so delta L is equal to 2L naught. Okay, so or twice of 0.04. So delta L will give you the value 0.08 meter. If you put all these numbers here, so you can say the work done is half 1.8 times 1.8 times 9.81 times 0.08. So if you simplify this, you have a work done is equal to 0.706. If you round it off, W is equal to 0.71, which is joule. So okay, the C is your option. Okay, let's see the question number 11. Question number 11 is, a wind turbine is used to generate electricity when the wind speed is 10 meters per second. It is a speed. The power input into the wind turbine is 3.2. This is power. Okay. Calculate the mass of the air per second. Okay. So mass of the air per second, you need to find, basically, if you see the expression, it says mass per unit second, that means mass m upon t. That's what you need to find turning the turbine. So we can start like okay, so P is equal to energy upon time, and energy is equal to power into time, or E is half m v square equal to pt. So you can rearrange and you can make m by t as your subject. If you can rearrange, and m by t would be equal to 2p by v square. Then you just put the numbers. 2 times p is 3.2 into 1000, which is kilo. Okay, 3.2 thousand divided by v square. V square is 100 square. 10, sorry, it's a 10, so it is a 10 square, which is equal to 100. Okay, so if you solve this, so m by t, mass per unit time or mass per second, answer would be yeah, it's a 64 kilogram per second. So this is your option. Question number 12. Under certain condition, many materials obey Hooke's law. State Hooke's law and describe the condition under which it is valid. So you just need to give the statement of the Hooke's law. Remember, Hooke's law is say that the um, elastic restoring force is directly proportional to the extension. This is mathematical relation. So elastic restoring force is directly proportional to the extension, providing that you don't cross, providing that limit, elastic limit does not cross. So you can say that within the elastic limit, the extension is directly proportional to the force. So basically, you can say that the elastic restoring force is directly proportional to extension, or extension is directly proportional to the deforming force. So both the statements are correct. And meaning, so this is the condition within the elastic limit, and this is the relation between force and the extension. Okay, so part B is describe the behavior of spring when it is stretched beyond the region where Hooke's law is obeyed. So of course, if you cross the Hooke's law is obeyed, it is stretched beyond the region. Okay, if you cross the limit, then what happens? You have a large deformation or large extension for a small force. So if you cross the limit, that means you have a permanently deformation and there will be a large extension for the same force. That's it for today. Thank you very much. See you in the next video.